On the afternoon of March 8, 1862, the history of naval warfare was rewritten in fire and splintered oak. In the calm waters of Hampton Roads, Virginia, the United States Navy's powerful wooden frigate, the culmination of centuries of shipwright tradition, unleashed hell against a strange, sloping beast approaching from the river. They fired point-blank broadsides that would have shattered any hull in existence. But the shells didn't penetrate. They bounced off. The CSS Virginia was not just a ship. It was a moving fortification, an iron monster that rammed and burned the wooden fleet with terrifying impunity. By sunset, the blockade was broken. The world's navies were instantly obsolete. Panic gripped the North. But the following morning, a bizarre silhouette appeared on the horizon to challenge the monster. It looked less like a warship and more like a metal raft carrying a solitary tin can.
This is the story of the USS Monitor and the CSS Virginia, and the engineering revolution that sealed the fate of wooden ships. We will dissect how they were designed and why they changed warfare forever. When the sun rose on March 9th, the smoke from the burning USS Congress was still drifting over Hampton Roads. The previous day's massacre had confirmed the Union Navy's worst nightmare. Their wooden fleet was defenseless. The blockade, the North's primary stranglehold on the Confederate economy, was effectively broken. If the Virginia could destroy 2 frigates in an afternoon, there was nothing stopping it from steaming up the Potomac to shell the White House or breaking out into the Atlantic to terrorize New York City. In Washington, the mood was apocalyptic. Secretary of War Edwin Stanton famously paced his office, convinced the rebel monster would shatter the Union war effort before the week was out. But the Navy had known this day was coming. Months earlier, spies had reported that the Confederates were raising the burnt hull of the USS Merrimack and plating it with railroad iron. The Union needed a counterweapon, and they needed it yesterday.
The response was a desperate strategic gamble. The Navy's ironclad board had initially favored traditional designs, broadside ironclads that were essentially wooden frigates wrapped in armor. But with the Virginia nearing completion, they had no time for tradition. They turned to John Ericsson, a brilliant but volatile Swedish engineer whose designs were so radical they bordered on heresy. Ericsson proposed a ship that violated every rule of naval architecture. It had no sails, no masts, and almost no hull above the water. It was a floating battery designed solely to carry 2 massive guns into a kill zone, fire, and survive. The Navy was skeptical. One officer called it a cheese box on a raft, but they were also out of options. They gave Ericsson a contract with a punishing clause. The ship had to be built in just 100 days, and if it failed to perform, he would have to refund the government every cent. It was an engineering sprint unlike anything in maritime history. At the Continental Iron Works in Brooklyn, the keel was laid on October 25, 1861. For the next 3 months, foundries across the North worked around the clock, casting parts for a machine that many believed would sink the moment it touched the water. They weren't just building a ship. They were building a prototype for a new kind of warfare, racing against a Confederate monster that was already afloat. To understand why the duel at Hampton Roads became a stalemate, we must look inside the radical geometry of John Ericsson's creation. The USS Monitor was not a ship in the traditional sense. It was a semi-submersible gun platform. When we peel back the iron plating in this cross-section, we see a design obsessed with minimizing the target profile. The hull itself is barely visible. With a freeboard of only 18 inches, the Monitor sat almost entirely underwater. This was a deliberate defense mechanism. Enemy shells had almost no vertical surface to hit. The vital machinery, The boilers, the steam engines, and the magazine was submerged well below the waterline, protected by the ocean itself. But the defining innovation sat directly amidships, the world's first revolving gun turret. Traditional warships, like the CSS Virginia, fought with broadsides. They had to steer the entire ship to aim their guns. Ericsson's solution was a cylinder of 8-inch thick iron, 20 feet in diameter, housing two massive 11-inch Dahlgren smoothbore cannons. The turret rested on a central spindle driven by a dedicated steam engine. By engaging a set of gears, the crew could rotate the entire 120-ton structure, tracking a target regardless of the ship's heading. This meant the Monitor could fire in any direction while retreating or stationary, a tactical flexibility previously impossible. However, this innovation came with terrifying risks. The turret was not bolted to the deck. It relied on gravity to stay in place. To rotate, it had to be jacked up slightly on a central wedge, breaking the watertight seal. In heavy seas, water would surge under the turret ring, flooding the ship from the top down. Furthermore, the ventilation system was a critical vulnerability. Without sails or hatches, the crew relied on steam-driven blowers to pull fresh air into the hull through low-profile intakes on the deck.
If waves washed over these intakes, as they frequently did, the belts driving the fans would slip. The boilers would lose draft, the engines would choke, and the hull would fill with carbon monoxide and coal smoke. Ericsson had built a machine that was theoretically invincible to cannon fire, but fundamentally at war with the sea itself. It was a trade-off of protection over buoyancy, firepower over seaworthiness. And as it steamed south to meet the Virginia, the crew wasn't just fighting the Confederates. They were fighting a machine that threatened to suffocate them before the first shot was fired. At 8 a.m., the CSS Virginia steamed out from Sewell's Point, its captain intent on finishing the destruction of the Union fleet. The target was the grounded steam frigate USS Minnesota. But as the Confederate ironclad lumbered into range, the raft beside the frigate detached itself and moved to intercept. From the gun ports of the Virginia, the Union vessel looked absurdly small, a pygmy challenging a giant. But as the Virginia opened fire, the reality of this new era became violently clear. The Confederate shells, which had smashed through oak hulls the day before like paper, slammed against the Monitor's turret and simply disintegrated. For the next 4 hours, the two machines circled one another in a slow-motion industrial brawl at point-blank range. The distance between them frequently dropped to less than 50 yards. Inside the Monitor's turret, the experience was disorienting and deafening. The steam engine turning the turret was difficult to control. Once the massive cylinder started spinning, its momentum made it hard to stop precisely on target. The gunners often had to fire on the fly as the Virginia swept past their sights. When a Confederate shell struck the turret's exterior, the impact didn't penetrate, but the concussion was horrific, knocking men off their feet and shearing off bolt heads that pinged around the interior like shrapnel. We can see the tactical frustration in the trajectory analysis. The Monitor's 11-inch Dahlgrens were firing solid shot, massive cast-iron spheres designed to smash armor. When these shots hit the Virginia's sloping casemate, they shattered the iron plating and cracked the heavy timber backing, but they failed to punch through. This brings us to a critical operational constraint. The Navy Bureau of Ordnance, fearing the new Dahlgren guns might burst, had strictly limited the powder charge to 15 pounds. Had the gunners been allowed to use the full 30-pound charge the guns were designed for, our simulations suggest the Monitor would likely have cracked the Virginia open like an eggshell in the first hour. Instead, the duel devolved into a stalemate of endurance. The Virginia, frustrated by its inability to damage the cheese box, attempted a desperate maneuver, ramming. But the Confederate ship was heavy, deep-drafted, and slow. The Monitor was nimble. As the Virginia lunged, the Monitor turned, causing a glancing blow.
Because the Virginia had lost its iron ram beak inside the hull of the USS Cumberland the day before, the impact did more damage to the attacker, springing a leak in the Confederate bow while merely denting the Monitor's armor belt. The turning point came not from a hull breach, but a design oversight in command and control. The Monitor's pilot has a small iron box located on the foredeck, separate from the turret, was the ship's eyes.
Inside stood Lieutenant John Warden. A Confederate shell exploded directly against the pilot house viewing slit. The explosion drove iron splinters and gunpowder into Warden's eyes, blinding him instantly. The force of the blow partially tore the roof off the pilot house. Communications between the pilot and the turret, already difficult due to the noise, collapsed entirely. The Monitor drifted aimlessly into shallow water while the crew scrambled to establish command. By the time control was restored, the Virginia, low on ammunition and taking on water, had begun to withdraw toward Norfolk. The Monitor, under orders not to risk the ship further, did not pursue. The battle ended in a tactical draw, but the strategic result was undeniable. Thousands of rounds had been fired. Neither ship had been sunk. The era of the wooden warship had ended not with a whimper, but with the ringing of iron bells that echoed around the world. While the Battle of Hampton Roads proved the Monitor was invincible to enemy fire, it concealed a much darker reality. The ship was a death trap in open water. The very features that made it a perfect harbor defense vessel, the low freeboard and the heavy top-mounted turret, made it hydrodynamically unstable in the ocean. John Ericsson had designed the Monitor as a raft for calm rivers and bays, but strategic necessity forced the Navy to tow it along the Atlantic coast. This exposed the design's tragic flaw. The ship lacked reserve buoyancy. In heavy seas, it didn't ride over the waves, it plowed through them. On December 31st, 1862, while being towed off Cape Hatteras in a gale, the Monitor met its true enemy. As the waves grew, the low hull was completely submerged. The turret, held in place only by gravity and its own weight, became a liability. The caulking beneath the turret ring loosened by the constant pounding of the sea washed away. Water poured into the hull, not just through the turret base, but through the hawse pipes and the ventilation intakes. The pumps, designed for minor leaks, were overwhelmed. As the water rose in the boiler room, it extinguished the fires. The steam pressure dropped, the pumps died, and the engines fell silent. The Monitor was no longer a warship. It was 1,000 tons of iron seeking the bottom. The cheese box had become a coffin. When it finally slipped beneath the waves, it took 16 officers and men with it, settling upside down on the ocean floor. A victim not of Confederate guns, but of its own radical geometry. It was a tragic end for a machine that had existed for less than a year. Yet, in that brief flash of time, it had rendered centuries of naval tradition obsolete. The Monitor proved that the future of warfare did not belong to the largest ship or the one with the most guns, but to the engineer who dared to reimagine the physics of the battle. The wooden walls were gone. The age of iron had begun.